We are recording now, and I just want to say how happy I am for those who are absent getting to see this video. I have no problems with you being absent. All right, look over here at this cart. I'm going to ask you all a question. Now watch what it does. See this cart? Watch what it does. Well, if you're watching, I'm not going to do that again. What are some things I could measure? Don't say anything out loud yet about that cart from the time I touched it until it stopped. I can measure some things. All right, be thinking of one. You can't say more than one. Measurements. Now, I might just call on you. You don't have anything in mind. Have you got something in mind? Do you know what you're going to say if I call on you? Okay, tell me one thing you could measure, Nate.
Distance.
How far did it go the distance? You could measure that. Yes, absolutely. What's another thing? Now, if he got yours, you've got to hustle and think of another one. What's another thing, Elizabeth?
Speed.
The speed. How fast was it traveling? What's another one? Jaden. I got yours, didn't we? We already got yours, didn't we? What's another one, Jackson?
The initial force.
Force. Yeah, my finger applied a force to it. Sure, that could be measured. What else can be measured, Mary? What? The what?
The volume
What'd you say? The volume?
of
The volume of the cart. The size of the cart. The volume. Okay, you can measure things. Okay, we can measure things about the cart itself. And so I could make another list of several things there. The length, the width, the height. We could measure the weight, the mass. Do you want to put any of those down? But I'm really just talking about the motion. So all those things I just said, and yours was one of them, can be measured, but let's put those aside. What else about the motion can we measure? Maybe we got them all. Is there anything else, Jackson?
Resistance.
Resistance? That's still a force. Just a resistive force.
Torque.
It's a force. What else, Andrew?
acceleration.
Acceleration. Yes. That's a good physics word.
Not for this.
Because it was at rest and then it had to speed up. If it goes from zero velocity to something, it had to speed up and then it slowed down. All right. Who else had a hand up? Austin?
Could you calculate how much energy was lost due to friction?
Energy can be calculated, and that's a big thing. That could be talked about in a whole lot of different ways. We'll just write the word energy for now. What else?
Deceleration.
Okay, negative acceleration, speeding up and slowing down. In physics, that word applies to both. If it's slowing down, it would be negative acceleration, but we still use the word acceleration. There's at least one more thing. There may be more than that. You could measure. There's at least one more thing. Maybe I need to do it again. All right. Something you could measure from this moment to right there. Time. You can measure the time it was traveling. Yeah. Time is a measurement. All right. There are two kinds of measurements. So all these fit into two different categories of measurements. All measurements are either this or that. I'm going to tell you what they are. Anybody already know what they are?
I know that.
Yeah, we talked about that in chemistry, but that's not what I'm going to say.
Oh, vector.
Actually, measurements would all be quantitative. Observations can be qualitative, but they're not, I don't want to talk about that anymore. Because you could qualitatively say, yeah, speeding up. That's acceleration still. But that's not really a measurement. You didn't measure anything. All right. Look at this word. Vector. Measurements can be vector quantities or they could be scalar quantities. Each one of those is either vector or scalar. All right, I'm going to tell you the difference. You're writing all this down? Taking notes on paper? All right. Vector quantities include a magnitude and they include a direction. Scalar quantities include only a magnitude, not a direction. Magnitude means how much. That's what the word means. Magnitude is just the amount. Like if we're talking about speed, magnitude would be, well, what is the speed? How fast? 2 meters per second. See, that's a speed. That's the magnitude. Direction is, I think you understand that word. That means which way is it going? What's the direction? Okay. If it's scalar, it doesn't have a direction. Can you look up there right now and identify at least one that has no direction ever? Time doesn't have a direction. Something can go forward or it can go backwards. See? But time cannot go backwards. It can't go to the left or right. It can't. It has no direction. So time is scalar. Time is scalar. All right, let's go through all of these, though. How much time do we have? We still have 5 minutes. Distance is scalar. Doesn't have, if I say, what's the distance the cart traveled, you just measure it and you say it traveled 30 centimeters. You don't tell me which direction it went. But there's another term I want you to write down called displacement. Displacement literally means change in position. Okay? Change in position. What's the change in position of the cart? Well, that is a vector quantity, displacement, because you would have to say, well, it moved 30 centimeters north. That direction is north. Or if that you think of that as an x-axis, the way you're looking at it, you'd say it moved 30 centimeters in the positive x direction. But it has to include a direction if I ask you what is the cart's displacement. If I ask what's the distance it traveled, there's no direction, just how far it got. See the difference? Okay, speed. I'm going to tell you that speed is scalar. It doesn't have a direction either. If I use the word speed in physics, it's scalar. How fast was the cart moving? Okay, it was moving at 1 meter per second at some point. Of course, you know it sped up and it slowed down. But at some point, we measured its speed to be 1 meter per second. You don't have to say it's going north. You don't give a direction if I ask what's the speed. But there's another word. I'm going to put the other word, I'm going to squeeze it in here. It's velocity. Now you probably know velocity means speed. And those words are synonyms, aren't they? But in physics, speed is scalar and velocity is vector. So they're not exactly the same thing. If I say, what's the speed of the cart, and you say 1 meter per second, then, and I say, good, that's a good answer. Then I say, well, what's the velocity of the cart? You have to say, well, it's 1 meter per second, and you have to give a direction, north. Or it's 1 meter per second in the positive x direction if it's moving along an x-axis. Okay? So this word has a direction included. Even though these kind of mean the same thing, except this one has a direction. These kind of mean the same thing, only velocity has a direction. Okay? Vector quantity versus scalar quantity. Now the rest of these we will talk about later, but I'm going to go ahead and finish this. Force is vector. We won't get to force until chapter 4, I think. We're going to talk about force until we get to chapter 4, but it's coming up. Acceleration we'll talk about in this chapter. It is vector. And we've got to talk a little bit about that. There's more to that than just what's the direction it's moving. And we'll get that. We'll talk about that later. Energy we won't talk about until chapter 6, I think, is much later. But it's scalar. If something has 20 joules of energy, that's not in any certain direction. That's just how much energy is in the thing. So there's no direction to that. And we've already said time is scalar. All right, so what you've learned today, and we've only got a minute left, is the difference between vector and scalar quantities. You're going to read tonight about displacement. That's in section 1. And it will explain, hopefully, what it means to be vector. And then you're also going to read about speed and velocity. That's in section 2. And see what the difference there is. All right, that's your homework. You know what to do. We still have a minute and a half maybe when I'm finished. Anybody have a question?
The
Yes.
assignments will be, we will have to study those